Good to go.
Okay, welcome to our workshop. Let's talk about objective of this lesson. It is intended to lead you through some basic computer concepts that will give you a better understanding of the computer. And we are planning to learn what's inside the computer and how it works. And we will discuss differences between operating systems, learn how to use and maintain a computer, and how to handle possible issues. So let's start with talking about what is a computer. It's a brief introduction to it. So in its original sense, the term computer referred to a person, to someone who performed mathematical calculations. And in doing their jobs, human computers were supposed to follow fixed rules, and they had no authority to alter them. So this term was later applied to mechanical devices that replaced human computers. But in a sense, they are doing exactly the same job today. So today, a computer is a programmable device which accepts data as input. It processes that data with a set of instructions, a program. It produces results as output, and it stores the results for future use. So what are the different types of computer? There are different types of computer of different scales. The biggest one of them are supercomputers, which are unique facilities that provide exceptional computing power. The term is used to describe fastest, high-performance systems that are available at any given time. Computers of this type are primarily used for scientific and engineering work that requires extremely fast computations. So currently, the most powerful supercomputer is Frontier, shown in this slide. It has achieved a performance of 1.1 exaflops. And 1 exaflops is a quintillion, or 10 in 18th power, double precision floating point operations per second. Then mainframes. They're a type of computers that generally are known for their large size, large amount of storage and processing power. And what's important is a high level of reliability. Mainframes first appeared in early 40s, and companies and governments use mainframes as central computers to carry out their operations. Mainframes are primarily used for mission-critical applications that need high volumes of data processing, such as census, industry, and consumer statistics. Most mainframes today are built by IBM. And then there are mini computers, also known as mid-range servers. They have many features and capabilities of mainframes computers, but are smaller. Digital Equipment Corporation introduced mini computers back in 1965 as a smaller and inexpensive alternative to mainframes. And the first, one of the first mini computers, PDP-1, was famous for being the computer most important in the creation of the hacker culture. And finally, microcomputer is a small personal computer that is typically used by only one person at a time. And that's mostly what we will be focused in today's workshop. So, okay, so what's needed for a computer to function? And there are three components that every computer needs, regardless of its types. It's a hardware, it's an operating system, and it's application software. So computer hardware is stuff you can touch as opposed to the software, which is abstract and which exists only in a virtual world of computer code. Hardware is made of materials, mostly metals and semiconductors, and it includes various components that are required for computer to run. Software, in its most general sense, is a set of instructions or programs instructing a computer to do specific tasks. All computer programs such as executable files, libraries, and scripts can be defined as software. Software is stored in computer memory, and you cannot physically touch a software. It consists of instructions that, upon execution, instruct hardware to perform tasks for which it was designed. At its lowest level, an executable program is composed of machine language instructions specific to a particular processor. So what is machine language? Machine language consists of groups of binary values describing processor instructions. These values change the state of the computer from its preceding state. For example, an instruction may change the value stored at the particular memory location inside the computer. And this effect you cannot directly observe. But on the other hand, instruction may also cause something appear on the screen of the computer systems, and such state change will be usable by the user. So the processor is the main part of the computer that carries out instructions in the order they are provided, unless it's instructed to jump at a different place in the code. And there are two types of software, two main types. This is system software, also known as an operating system, and application software. So what is operating system? Operating system is designed to operate the computer hardware, to provide basic functionality, and to provide a platform for running application software. Operating system is an essential collection of computer programs that manages resources and provides common services for other software. Operating systems are composed of system software and device drivers. Bootloaders, command line shells, device drivers, and Windows managers are core parts of operating systems. Device drivers are programs that control a particular type of device that is attached to a computer. Each device needs a corresponding device driver. So thus a computer needs multiple device drivers. Also, operating system come with software designed to help users in maintaining and caring for their computers. So this software is referred to as utilities. So in a general sense, an operating system can be compared to the driver of a car. The driver might appear as if all he's doing is instructing the car where to go. However, in fact, he is bringing in a variety of information from different parts of a vehicle. He's also taking in information that is given to him, like a map, instructions for where to travel, and road signs that he encounters along the way. So an operating system within a computer interacts with a variety of components inside. In the same way as a driver interacts with a car. An operating system basically acts as a middleman between users and the computer by creating an environment that allows them to interact with the computer as efficiently as possible. And finally, an application software. It's a software which you really use to solve the problems. It uses the computer system to perform useful work or provide entertainment functions or which are beyond the basic operation of the computer itself. So in order for operating system, in order for an application software to run, it requires an appropriate environment, which is known as a platform. Platforms can refer to many things, depending on the context. The term platform may refer to a hardware or to an operating system. A platform can also be a web browser or other underlying application software, such as Java runtime or QuickTime, for example. Computing platforms can be thought of as the stage on which computer programs can run. As an example, operating system run on hardware. So when it comes to operating systems, hardware is a platform. In the case of programs like Office or Photoshop, they are both programs that run on an operating system. This means that their platform consists of the operating system and the underlying hardware combined. And as a final example, Java applications only need Java runtime environment to operate, which means they can be run on any computer regardless of its hardware and its operating system, as long as Java runtime is installed on it. But despite the fact that a lot of things work across different platforms, some more complex programs like video editing software or games do not run well or do not work at all across all platforms. And hardware and software require each other, and neither one can be used without another. So let's do a quick poll now. The poll 1, components of the system. So Sarah, can you please bring up poll 1? Yeah, and the question is, what components are required for a computer to function? Oh,
Let me know when you want to close the poll too.
yeah, I think we are almost all done. And yeah, let's close the poll.
All right. And I can, did you want me to share the results?
Yes, and
Okay.
I think I confused you because the correct answer was actually missing from the answers. Yes, we do need hardware, we need operating system. Yeah, but we also need application software. And these are the three main components as we just discussed. Sorry about that. I messed up and I somehow managed to not to provide the correct answer. But most of you got it correct anyway. You need device drives, operating system, and what's missing part there is an application software. that you need to actually solve some problems. Okay. Can you close it? Yeah. So, okay, so what's inside the computer, you might be wondering. What you'll find inside when you open it up. So modern computer contains lots of things. So what exactly is inside and what are the function of all of its components? I'm first going to take you through a quick overview of the most common hardware components, and we will then take a closer look at some most important ones. So we have a computer case. It's basically just a box that houses the internal components of the machine. Its purpose to protect and to cool the components of your computer. We have a power supply unit, which converts mains AC power into regulated low voltage DC power for computer internal components. There are storage devices like hard disks and flash drives, which enable users to store all kinds of information, including videos, pictures, and raw data. Input-output devices allow computers to communicate with users. The most common input devices are keyboards, mice, joysticks, various controllers, while the most common output devices are monitors, speakers, and printers. In a computer, random access memory serves as its main memory. It's commonly called just memory. And in any digital computer, the CPU is the main brain, which does nearly all the calculating. It's the main microchip in the computer that distributes tasks to all other components of the computer. Computers have graphic processing units, which are specialized processors. They were originally designed to accelerate 3D graphics renderings. There are different types of GPUs. GPUs can be integrated with the computer, can be part of the CPU, and there are discrete GPUs that are sold separately. Compared to integrated GPUs, discrete GPUs have much greater processing capabilities. GPUs today are more programmable than ever before, though. And in addition to traditional graphics rendering, they are now used in a wide range of applications. And the last but not least is the motherboard, which is one of the biggest boards in a computer's case, and it forms the backbone of the device. Besides managing power, motherboard enables communication between the computer's CPU, RAM, storage, and other components. Of course, some computer components can be combined on a single chip. GPUs are often integrated into CPU chips, for example. Almost all computer components can be integrated into a single chip, including CPUs, GPUs, memory interface, and input-output interfaces. And this type of microchip is known as a system on a chip. Computers can be made smaller and more energy efficient with a system on chips. System on chips may, however, not offer the same performance as dedicated discrete CPUs or GPUs because of power and space limitations. So as we move forward, let's take a closer look at some of the most important computer components. CPU is one of the main components of your computer, which is responsible for processing the data. Processors are electronic circuits used by computers to execute instructions. There are three main components of any CPU, regardless of its type. It's arithmetic logic unit, control unit, and registers. Well, it's a very basic example, as modern, more sophisticated CPU chips have additional logic, but there are at least these three main components in all CPUs. So what are the functions of these main CPU components? So arithmetic logic unit carries out arithmetic operations such as addition, subtraction, multiplication, etc., as well as logic operations, or, and, not, etc. Control unit reads and interprets instructions from the memory. It controls the operation of arithmetic and logic unit, memory, and input-output devices, telling them how to respond to the program instructions. And finally, registers, they are high-speed storage areas in the CPU. So whenever data is processed, it must be stored in a register. In addition to these components, CPUs have an internal memory system called a CPU cache. The processor cache is a bank of extremely fast memory that facilitates efficient communication with the main memory. We'll talk about this a little bit later. Graphic processor units have become one of the most important types of computing technology today. GPU development had been driven by the gaming industry predominantly. And GPUs are best known for their capabilities in video rendering, because they were originally developed to accelerate specific three-dimensional rendering tasks. But over time, these fixed function engines became more programmable and more flexible. So while graphics processing remains their principal function, GPUs have evolved to become more general purpose parallel processors. Today, they are handling a growing range of scientific and engineering applications in areas such as machine learning, which cannot basically be done these days without GPUs. All machine learning training are specifically designed for GPUs. And also such areas as particle and fluid simulations, drug designs, and electronic structural calculations take advantage of GPUs and can run much faster on these specialized GPU units. Although most modern CPUs are equipped with integrated GPUs, the performance of these integrated GPUs as compared to discrete GPUs is much lower. So what's the main difference between CPU and GPU, and why GPUs are so fast? Well, they are designed for different use cases. A CPU is designed to handle a wide range of tasks quickly, as measured by CPU clock speed. But they are limited in the number of tasks that can be running concurrently. So thus, by design, CPUs are more suitable for serial instruction processing. The CPU focuses its small number of cores on individual tasks and on getting these tasks done quickly. GPU, on the other hand, consists of thousands of smaller, less powerful, and more specialized processing units, or cores. But by working together, the cores can deliver massive performance when a processing task can be divided up and processed across many cores. For example, when images are processed, they are divided into small blocks, and each processing core works on a small part of the image. NVIDIA calls its parallel processing platform Compute Unified Device Architecture, or CUDA. CUDA cores are processing units inside an NVIDIA GPU, just like AMD's stream processors are inside AMD GPUs. So how does it work? It might be helpful to consider an example to understand how CUDA cores help to accelerate computing. So you can compare a processor, a GPU processor, to a water tank in the sense that it holds data to be processed. So the job of emptying the tank will require you to use pipes, and you will be able to empty the tank faster if you connect more pipes to it. So CUDA cores act as if they are pipes connected to the processor. With a larger number of CUDA cores, processing can be done at much faster rate due to the fact that this can be done in parallel. But CUDA cores are only a small part, not small, it's a large part, but it's only a part of what GPUs offer. In addition to CUDA cores, they are equipped with cores that are specifically designed for ray tracing and for tensor operations common in artificial intelligence workloads. And as we enter the era of artificial intelligence, computers are being increasingly equipped with neural processing units. And integration of neural processing units into CPUs is nowadays becoming a standard practice. So let's take a look at what a neural processing units are and how their performance is measured. Neural processing units, or NPUs, they are special purpose processors designed to accelerate and efficiently handle the computations required to process neural networks. Matrix multiplications is the fundamental operation in neural networks and other AI applications. The operation is performed by multiplying the corresponding elements of each matrix together and accumulating the results. So in order to perform this computation efficiently, NPUs have a large number of specialized multiplier accumulator units, MAC. A MAC unit can execute both operations in a single clock cycle. Neural networks typically represent data as low precision 8-bit integers, and this facilitates efficient processing. Using low precision integers allows for a significant reduction in memory requirements and the complexity of MAC units compared to representing data with high precision integers or floating point numbers. So the MAC unit for 8-bit integer precision are simple. They consume very small power and they can be packed very tightly. And furthermore, using low precision integers also improves computational efficiency. This reduction in precision allows computations to be executed more quickly since fewer operations are required. Performance of NPU units is measured in TOPS, or trillion operations per second. TOPS provides a fairly rough estimate of NPU performance, but this metric does not accurately reflect the real-world AI PC performance. So nevertheless, stops can be used as a quick way to determine whether an NPU can handle a particular program. For example, Windows Copilot Plus advanced AI features require a powerful NPU with at least 40 TOPS. So when shopping for a new PC, you might want to consider the requirements of AI tools that can make your life easier. So how can NPU be used? Microsoft Copilot Plus brings several next generation AI Windows features to your local computer. I'd like to highlight some of these features. So with Recall, you can find and organize things using a personalized semantic index. With live captions, you can translate audio from over 40 languages into English subtitles instantly, automatically, even while you are offline. And with Co-Creator, you can create images using text prompts. And it can also be done just very close to about real time on your local computer. So the idea of equipping computers with powerful NPU units is that you don't need to connect to large servers to get some AI inference get done. You can do it locally. So there are also software toolkits for optimizing and deploying deep learning models on NPUs if you want to experiment with your own machine learning models. Okay, how are we doing in time? It's 1:37. I have another 37 minutes. Okay. So during the course of computing, data and instructions enter a computer through the input devices, and they are then stored in memory for future processing. In computers, there are two kinds of memory, primary and secondary. Random access memory, or RAM, is the primary internal storage area of the computer for code and data that needs to be operated on quickly. RAM is located on the motherboard and is connected directly to the CPU. Due to this, data can be read from and written to primary storage extremely quickly. Using RAM, CPUs can interact with the information held in memory quickly and efficiently. So the RAM can be compared to your desk's working area. When your desk is full, you need to organize and store stuff, otherwise everything will take forever and things will fall off. As the amount of available RAM is limited, it needs to be cleared and refilled constantly. But you won't have to worry about that. It happens automatically on all computers. RAM is the one component of the computer that determines how fast it runs. RAM is called volatile memory because the information stored in it disappears when the computer is turned off. RAM is plugged into special slots on the motherboard. There is a wide link known as a bus from the memory to the CPU. DDR4 bus can transfer 64 data bits in one transaction, for example. The memory bus is part of the collection of transport buses that transfer information between parts of the PC at high speeds. Each motherboard has a fixed number of slots for RAM. Most often there are 2 or 4 slots for memory. And also it's possible to use certain types and sizes of RAM with specific motherboards. So check the specifications of your motherboard before you purchase RAM to upgrade your computer. A computer's performance can be dramatically slowed down by a shortage of memory. Although modern computers have plenty of RAM, they can still run out of memory in some situations. Well, the most obvious is simultaneously running multiple memory-intensive applications such as video editing software, searches against large databases, protein database, for example. A browser with a great deal of tabs open can quickly exhaust all computer memory as well. You can solve the problem by installing more RAM or running fewer programs simultaneously. So, okay, before we discuss long-term data storage, let's take the next poll number 5, CPU versus GPU. And try to... Sir, can you bring up the poll?
Sorry.
Please,
The
CPU versus
one.
GPU.
Ah, yes.
There we go. So yeah, this is a question about differences between CPUs and GPUs. And please select the right statement here. I'll give another 20 seconds for you to answer. Yeah, we have it 71% participated now, and yeah, we are on the right track. Oh, can you share the results, Sarah, please?
Yep.
Yeah.
There we go.
There we go. So yeah, CPUs are best for carrying out serial instructions. And GPU cores are not more powerful than CPU cores. Each GPU core, is a matter of fact, runs quite a bit slower than CPU core, and it's not capable of performing as many various instructions as CPU core does. But GPUs are more powerful because they have thousands of cores, not because one core is more powerful. All right. So we have another 20 minutes. I guess we can discuss storage, and then we'll probably have before the break. Oops. Yeah, long-term data storage. So computers read both data and programs from storage to perform various tasks. So thus, for data to be processed, it must first be stored in a way that makes it accessible to the CPU. There are many different storage devices available today that are capable of storing data for an extended period of time. Storage devices such as hard drives and flash drives contain non-volatile memory, which is like paper. Even though it can be destroyed or erased, if properly cared for, it can last for a very long period of time. But how digital computers store information? The smallest unit of storage in a digital computer is known as the bit. A bit stores just 2 values, a 0 or 1. In computers, everything is expressed as ones and zeros. So that language of ones and zeros is called binary code. So what is a byte then? There is too little information in a bit to be useful. Bits can be grouped into bytes to store useful information. An individual byte can store enough information to be meaningful. The term byte was historically used to describe a set of bits necessary to encode a single character of text. In computing, a byte is typically 8 bits long and can store 256 integer values between 0 and 255. But how information such as text characters is represented in a computer? American Standard Code for Information Interchange, or ASCII, was the first standard character set for computers and electronic devices, which was developed to facilitate communication between computers of different makes and models. ASCII assigns standard numeric values to letters, numerals, punctuation marks, and other characters used in computers. The character sets used in modern computers, in HTML, and on the internet, they are all based on ASCII. In this character set, a character is represented by a group of 7 bits. So there are 128 characters in total. For example, an ASCII uppercase literals from A to Z are represented by decimal numbers in the range of 65 to 90. So capital A in binary is 64 plus 1, which is 65. And oops, oh, sorry, let me get back. Yeah, there are links here to the converter, which is online, and it is very helpful when you want to convert between different encoding systems and units. If you worked with image editing or web page design, you are probably familiar with hexadecimal colors. In this color coding system, intensity of each of the 3 primary colors, red, green, and blue, is represented by 2 hexadecimal digits between 0 and FF to create 255 possible values, and thus resulting in more than 16 million possible colors. The hexadecimal number system is a type of number system that has a base value equal to 16. It's also pronounced sometimes as hex. Hex numbers are represented by 16 symbols. The symbols are 0 to 9 and letters A to F. So 21, for example, in decimal code would be represented as 16 in the power 1 plus 5, 16 in the power 0. Hexadecimal number system provides a convenient way of converting large binary numbers into more compact and smaller groups, because 4 binary digits are represented with just 1 hexadecimal digit. This system is commonly used in computer programming and microprocessors. It's used to describe locations of memory for every byte. These hexadecimal numbers are also easier to read and write than binary or decimal numbers for computer professionals. Well, there is a wide number of advantages in data science field, AI field, and machine learning in using this system. But the major disadvantage is that it may not be an easy to read and write for people. And also difficult to perform operations like multiplications, divisions using hexadecimal number system. And finally, the octal number system is a type of number system that has a base value equal to 8. So let's consider a practical example of using it. Linux file system permissions. So what are file system permissions? So securing your data stored on a Mac or Linux system requires you to understand file permissions, how they work, and how to change them. Permissions determine who can access files and directories and how. And Linux has 3 types of permissions: permission to read, to write, and to execute. The permissions are each controlled by a single bit that can be toggled on or off. Here, 0 means there is no permission, and 1 means permission is allowed. There are 3 sets of permissions applied to different group of users. The first set of permissions applies to the owner of the file. The second set of permissions applies to the user group that owns the file. And finally, the third category of permissions is known as others. That is permission for everyone else. So permissions are thus described by 3 groups of binary triplets. Here, if you have permission to read, write, and execute, all bits should be set, and the octal value describing this permission is 7. Now, if there are only read and write permissions, only read and write bits are set, and these bits correspond to the octal value of 6. It's 2 in the power 2 plus 2 in the power 1. 4 plus 2, 6. And if you want read-only permission, that will be 2 in the power 2, which equals to 4. Because each binary triplet has 8 values in the range of 0 to 9, it's very convenient to present it with a single octal number. Yeah. Let's do a quick test on the Linux permissions on the practical example. So Sarah, please, could you please bring up poll 2 permissions?
Yep, started.
There you go. So what numeric code would you use if you wanted the permission to be read, write, execute for owner, only writable for group, and readable and executable for everyone else? And just by looking at this table, you can quickly find out what the number in the octal system you would use to describe this permission.
Then maybe after this, it's the good time for the break.
Yeah, it's good time for break, sure.
Awesome.
So we can leave this poll while we are having a break, and we will start with discussing the results. And it's 1:55 now, so I'm gonna come back to at 2:05, I think.
Perfect.
10
Yeah.
minutes.
2:05 or 2:35 in Newfoundland. I'll pause the recording. Restart.
All right. So let's a quick look. 725 is the right answer. Well, I mean, the first digits is clear. There are all three permissions set, all three bits are turned on, so that's 7. What about write permission? Should it be 6? No, that's not really 6. Write permission is a second bit, and its value is 2 in the second power in power 1, so it's 2. And finally, for the last bit, there are 2 bits set, read and execute, and this would be 4 plus 1, which is 5. All right, so next, we will talk about storage devices and how to choose the right device for your computer. So we talked about bits, and what we need to do now to store data is to store bits. And bits can be stored on pretty much any physical medium that has at least 2 separate states. The 3 main types of storage media are magnetic, optical, and semiconductor. In a magnetic hard drive, bits are represented by tiny magnets or magnetic dipoles with opposing orientations. One orientations is 0 and opposite orientations is 1. And reflectivity is used to encode bits on an optical disk. And in a semiconductor chip, bits are stored as electric charge. An uncharged memory cell represents one, while a charged memory cell represents 0. So both RAM and storage devices store bits of information, but how do they differ from one another in terms of their primary function? The primary purpose of storage devices is to store data that is not being used by CPUs. This includes long-term data storage and storage of temporary files. So storage devices serve as an addition to the computer's main memory. It's for this reason they are often referred to as secondary memory. It's important to understand how information flows in a computer in order to understand how primary memory differs from secondary memory. So data and programs, enter the computer through input devices. A storage medium is where data is stored for future use after it has been entered and generated by an application. It's common for storage devices to be large, but they are slow to respond. Direct access to memory of storage devices would be very inefficient because CPU would need to wait for data. So in order to improve the efficiency of the system, memory is organized in such a way that access time for running processes is minimized. And this is done by organizing memory access in a specific memory. All programs and data are first stored in secondary memory. Secondary memory cannot be accessed directly by a CPU. This would be a bottleneck. Now, the operating system loads instructions and data into random access memory in order to execute any program. RAM is smaller, faster, and it can be accessed directly by the CPU. As only the ready-to-run processes are loaded in primary memory, the CPU can access them efficiently, which optimizes the performance of the systems. So what to consider when buying a data storage device? The performance of storage devices is very important for many reasons, not only for the safe and convenient storage of data, but also for the efficient operation of the computer system as a whole. A computer storage device is characterized by two basic performance measures: sequential read-write speed and random input-output operations per second. IOPS are very important in making a computer feel fast and responsive. Since an operating system reads and writes a lot of small files, including configuration settings, logs, and various temporary data. The speed of sequential reads and writes, on the other hand, is more important for large file transfers. Solid state drives and hard drive disks are two main types of secondary storage devices that are widely used today. Hard drive disks are mechanical drives where data is written on a spinning magnetic disk. Well, they are inexpensive and they are good for long-term data storage. However, performance of HDDs, and particularly IOPS, is limited by the access time, the times it takes before the drive can actually transfer data. In a hard disk drive, data transfer is sequential because it is read from a track on a hard disk. And there will be a delay before drive is ready to transfer the data. For example, if request came and the data is located at this sector, drive would need to wait until the disk rotates so that the sector is under the read-write head. Solid-state drives use semiconductor media known as flash memory. One of the characteristics of flash memory that sets it apart from other storage media is that it can only be erased in large blocks at a time. So this term flash was coined by one of the inventors because the process of erasing all the data from a semiconductor chip reminded him of the flash that comes on a camera when it takes pictures. Flash memory has become a popular storage medium. In fact, flash memory has mostly replaced the magnetic hard disks that used to be common in computers. So what makes flash memory so great is that, well, of course, it's solid states, meaning that it doesn't have any moving parts. Flash memory is also very fast because it doesn't have delays in data access characteristic to mechanical drives. There is a consistent read-write performance because data location is irrelevant. They can read and write to any memory cells without the delays of the rotating disks. And speed up of accessing random small files on flash memory is dramatic. So flash memory is very good for the operating system, for your computer to feel responsive. Well, flash memory is like a battery. And with time, it's gonna leak, and sooner or later, it's gonna lose its charge and lose its information. So how long can flash media safely retain data? Um, well, if memory cells in the flash uh, in the flash drive are not recharged, it will lose its charge and lose the data. It's necessary to full discharge the memory cell before it can be used to write new data to. That's another feature of the flash memory. But each time the memory cell is erased, it becomes more leaky. So the barriers retaining electrons in their wells are getting damaged. And as a result, data retention degrades. So the endurance standard requires memory cells to retain data for at least 10 years if they are lightly used. And by lightly, it means like less than 10% of maximum erase charge cycles. However, heavily used cells are required to retain data only for 1 year. So yeah, those are drawbacks of the memory cells. And also, although SSD prices are gradually dropping, they are still more expensive than hard disk drives. A good HDD sale price is $24 per 1 terabyte currently, while 1 terabyte of SSD storage will cost you around $60 to $100. So for you to make an informed choice when selecting the right storage device, you need to have an understanding of the existing technologies in this rapidly evolving field, how these underlying technologies impact system performance and data storage reliability. Well, when you're searching for an SSD, there are a lot of terms that you will come across, and you may feel overwhelmed by the options that are available for you. It's likely that you will come across terms like SLC, MLC, TLC, SATA 3, NVMe, and M2. So what does it all mean? Let's take a quick look. So what is NVMe? Flash memory is so fast that 600 megabytes per second common serial ATA interface used by mechanical drives was not able to keep up with the requirements of data transfer speed. And the new interface, known as Non-Volatile Memory Express, NVMe, has been developed to address this bottleneck. Because it was designed from the ground up specifically for flash memory, it offers many advantages over SATA. The intention was to introduce a particular interfacing protocol that will efficiently work with SSDs. For this reason, NVMe is rapidly becoming the industry standard for servers operating in data centers, as well as desktops, laptops, and even gaming consoles of the next generation. So M2 drives, unlike regular HDD and SSDs, are not attached to a motherboard via a cable. Instead, they are inserted directly into the motherboard via a dedicated M2 connector port to PCI Express bus. Currently, an NVMe interface can use up to 4 PCI Express lanes for theoretical maximum transfer rate of 8 gigabytes per second over PCI generation 4. NPCI generation 5, which is already available on some high-end motherboards, the transfer speed will be doubled. So what are SLCs, MLCs, ALCs, TLCs, QLCs, and PLCs? So previously we saw that a media that has two states can store 1 bit of information at one location. A media must have more than two states in order to be able to store more than 1 bit at one location. A group of 2 bits, for example, would require 4 different states to represent all possible combinations of zeros and ones. Flash memory can store more than 1 bit in a single cell. For example, in SSD with single level cell technology, each cell can exist in either one of two states, storing 1 bit of information. The multi-level cell is capable of storing more information than a single bit. The term MLC is often used to refer specifically to two-level cells. Two-level cells store 2 bits of information, and they need 4 charge levels to do so, because there are 4 different combinations to represent all states of 2 bits. As of now, there are also flash technologies with triple and quad level cells, TLC and QLC, and penta-level cells are under development. So memory that utilizes multi-level cells has a higher density of information stored, so the price per gigabyte is lower when compared to memory that uses single-level cells. Multi-level cell technologies enable high-capacity SSDs to be manufactured. While MLC memory has the advantage of being less expensive than single-level cells, it is slower. It is high power. It has high power consumption, higher error rate, and its lifetime is shorter. Well, that's why high-performance memory cards still use SLC flash memory. All right, so let's bring up our poll number 3, flash memory. So for triple level cell, a cell that is capable to store 3 bits, how many charge levels do we need to use? And I'll give you a hint. Look at the slide, at the figure at the bottom of it. Oh, do we have? Okay. Okay, should we end the poll, Sarah, and share the results?
Sure.
Ah, there we go. Yeah, I mean, the answer is right here. So to describe all possible combinations of 3 bits, oh, my cursor keeps disappearing. We need 8 charge levels. The trick here is that each combination of bits is represented of the charge level between one of these intervals. And to describe all 8 combinations, we need 8 charge intervals. All right. Let's. So we have learned now what computers are made of. So let's move on to how to use a real one. In this section, I'll give you a quick overview of the operating systems and compare major operating systems that are currently available to help you decide which one is best for you. As we discussed, in order to interact with computer, you'll use software called an operating system. Essentially, an OS is a program that stands between your computer and anything else you run on it. Among its essential functions are file management, memory management, process management, input-output management, and peripheral device controls. Well, these days, a program can only concern itself with executing its core functions and let the operating system handle all basic system functionality. So Windows, macOS, Linux, and Chrome OS are 4 of the most popular operating systems used on desktop, laptops, and Chromebooks today. For desktop and laptop computers, Windows is the most used at 69%, followed by Apple's macOS at 21%, and Linux-based operating systems are at 7%, and Chrome OS at about 40%, 4%. However, Linux has completely dominated the supercomputer field since 2017, with all the top most powerful supercomputers in the world running Linux. So let's briefly review each one of them individually. And then look at some differences between these operating systems in terms of their design features and interfaces. So Windows basically is just the default OS for most people. It's the first one they get to know, and it allows the user to easily run daily tasks, such as internet browsing, gaming, office work. Windows is a private piece of software, meaning its source isn't publicly available. Only Microsoft has access to it. At first, users had to pay if they wanted to buy a copy of Windows or upgrade their Windows version. But with their latest releases, users can access most of the software functionalities for free and only need to pay to access some particular features. Another thing to keep in mind is that Windows shows advertisements within the operating system, so it can be thought of as an advertising platform as well. macOS should be still be here. macOS is built on top of a Unix-like operating system, which is why it shares many common characteristics with Linux. Unlike Microsoft, whose idea is to make the product as widely available and easy to get as possible, Apple aims to make their products top quality but pricey and incompatible with other hardware. You can run any software you want in their hardware. Well, you can't run any software you want in their hardware, and you can't install their software anywhere else than a Mac computer. Linux is the base of many open source operating systems. Unlike Windows and Mac OS, Linux isn't a single full operating system. It's rather a collection of programs, utilities, and a kernel. So what's a kernel? Kernel is the core component of the operating system. It's the piece of software that interacts the closest with the hardware and has complete control over all processes in the system. The kernel is responsible for low-level tasks such as disk management, memory management, task management, and so on. So when you install Linux, you have to choose from one of the available distributions. But what's a Linux distribution and why there are many Linux distributions? Well, overall, the Linux project has a huge amount of open source code developed by different communities. And when Linux was originally developed, distributions did not exist. So developers would download the kernel from kernel.org. They would use various complicated tools to compile it, install it on a system, then compile the individual pieces of software downloaded from FTP sites of various software development communities, and assemble this all by hand. Well, this was difficult to use. So the developer realized that it would be very helpful to provide a distribution of tools, rather a distribution of tools that users can use to set up their Linux systems quickly. It turned out there was not going to be just one distribution because there were many different use cases, and people wanted different sets of tools for various purposes. So these days, many different Linux distributions exist, each with its own goal and criteria for selecting software included with the operating systems. Some of the Linux distributions are known to be the most secure and stable systems out there. They're used in key spheres such as banking, finance, government, and military. As I mentioned above, Linux runs on most servers. It's used on most supercomputers and also on most cell phones. Android is based on Linux kernel. On the desktop laptop side of things, Linux usage isn't really as widespread. Back in the day, the learning curve necessary to use Linux was considerably higher than for the Mac OS or Windows. But this situation has been changing lately. Linux distributions put more focus on user friendliness, and it becomes easier to get computers with Linux installed by default. So what are the most widely used Linux distributions? There are three main families of distributions: Red Hat, Debian, and OpenSUSE. Linux distributions share the same operating systems and software at their core. It's the package management systems and tools that make the biggest difference between the distributions. The package management system is composed of two components: a low-level tool for installing individual packages and a front-end tool for performing more complex sections, such as updating the operating systems, installing groups of packages, and satisfying dependencies. We'll have a quick look. I'll do a quick demonstration of usage of using package managers in a moment. The lifetime of support is an important consideration when you choose a distribution. It's possible to try out the latest technologies and software with cutting-edge distributions like Fedora, but the support time for such cutting-edge distributions is usually short. It's no more than a year, 13 months for Fedora currently. So if you do your work on a computer, it's more practical to use a distribution offering a long support period, such as Ubuntu long-time support, 5 years, or Rocky Linux, just 10 years. So, and finally, there is also Chrome OS. That's the last OS we will look at. The Chrome OS operating system, well, it's basically a specialized operating system developed by Google exclusively for Chromebooks. Unlike traditional operating system, Chrome OS heavily relies on cloud-based services. The Chrome OS operating system was originally limited to apps that could run inside the Chrome web browser. But over the years, Chrome OS has evolved into a modern and actually quite versatile operating system. Besides supporting all Chrome OS-based stuff, Chrome OS can also connect to the Play Store and install almost any Android app. Linux applications can now be run on Chromebook models, on some high-end Chromebook models as well. And it is even possible to run Windows applications on high-end Chromebooks. But of course, using commercial software such as Crossover and Parallels to run them in a virtual environment. So let's compare operating systems more closely. First is the file system organization. Unlike Mac OS and Linux, Windows organizes files differently. In a sense that Windows use drives. So before you can access files located on a different drive, you have to change drive first. Linux and Mac share a similar file systems derived from Unix. And in these operating systems, there are no drives. Everything is a file, and all files are arranged in directories that descend from a single root directory. So an organized directory is essentially a tree with a unique root, and you can attach your devices, extra devices. For example, if you insert your external drive or CD-ROM, you can basically attach it to any point on the directory tree. They are most commonly attached, they call it mounted on the media directory or MNT. Well, while it doesn't really make much of a difference to the end user, it's something to keep in mind if you are used to navigating one type of the file systems. So let's have a look at the command shells now. Command shells are useful for running a software which does not have GUI. And there is a lot of scientific and engineering applications developed these days, which are command line only utilities. Linux and macOS fall in to the family of Unix-like file systems. Unix-like systems, which are designed as multitasking and multi-user operating systems. Furthermore, these systems are POSIX compliant. The POSIX standard establishes compatibility between operating systems. As a result, all the systems offer standard Unix facilities, and you can interact with them using the same commands. Using commands is very useful for automation of repetitive tasks, such as backing up files and running batches of data processing. Typically, you'll use a terminal to enter commands. A command line interface to a Unix-like operating system is called a shell. It works as an interpreter by accepting your input, executing a command based on it, and displaying its output after the command has completed. Both Linux and Mac have a Bash or Z shell as their default shells, while Windows has its own shell that uses quite a different syntax, command prompt and PowerShell. Learning Bash is probably the best option because this knowledge you can apply to most operating systems, especially taking account that Linux run on most HPC clusters. And you'd need to use terminal to interact with those powerful computers whenever you need to use them. So what is a package manager? What is a software package? And what is a package manager? Software packages are collections of executable. Software packages are collections of executable files, libraries, and other required resources, which are bundled together with instructions for installation and configuration. Packages basically are pieces of software that contain everything you need to use them in a single archive. Package manager is a software service, software utility, which is installed on top of the operating system that helps you to manage other software. Package managers download, install, and maintain various software packages, as well as system packages, kernel drivers, and utilities. A package manager keeps track of what software is installed on your computer and allows you to easily install new software, upgrade software to newer versions, or remove software that you previously installed. Package managers are super helpful, especially when you're installing and uninstalling things constantly. It's much more efficient to install programs through package managers than manually. Package managers are at the backbone of Linux distributions. So Linux always comes with a package manager by default. And there are two main file formats for Linux packages, Debian and RPM. And various Linux distributions use different file formats. RPM is the package format for Red Hat and Red Hat-based Linux family and OpenSUSE, while Deb is the package format for Debian-based distributions. opt is the package manager for Deb packages, while RPM packages are managed by DNF, successor of YAM. macOS doesn't come with a default package manager, but you can install a third-party one. And the most popular package manager for macOS is Homebrew. Starting from Windows 10, Microsoft provides App Installer, which can be viewed as a package manager. And one of the most popular third-party package managers available for Windows is Chocolatey. So let's take a quick look at one of the package manager to give you a sense of what it is and how to use it. I'm going to be using Debian Linux distribution, which I have running in my computer for this demonstration. And the command to use package manager is opt. So the first thing you can do is you can ask it how to use it, opt-help. And you will see the list of available commands for this program. Well, it can list packages, search for packages using keywords, show package detail, install, reinstall, remove, auto remove, automate, well, particularly remove all unused packages, and so on and so forth. So Linux distributions have precompiled software packages. And when you install Linux, apt knows what distribution version you are using and which repository to use. There are some software vendors who maintain their own repositories also, and their websites will have instructions on how to add them. So let's get a list of everything that's available in the current repository. And command is opt list. And you see there is quite a huge list of the available packages. And in Linux and Mac, we can count the number of packages. Let's do that for a quick look. And yeah, there is 62,000 of different packages available in the system. You can limit the output of the opt list to the packages which are currently installed by asking opt to list only installed packages. Installed. And you can see we have currently 1,300 packages installed. So when you're trying to install package, what you need to do? You need to know the name of the package. But you might not know the exact name of the package. Say we want to install OpenMM, and we try to do this using opt. When you're installing, you have to use sudo or on Linux, which basically elevates you to the administrator privileges, because opt will install packages system-wide. So sudo opt install, and say we want to install OpenMM. It will ask for password, and it will not find anything. So how can we find a package, exact package name that we want to install? You can do a search. And you see it, we found quite a few packages that have OpenMM somewhere, anywhere in the description of the package. So there is quite a few packages still. Well, another thing you can do list installed, but you can filter result to the packages that only include OpenMM. And for this, you will use grep utility, which is one of the user utility. Basically, grep will filter results based on the pattern that you provide. So it will filter the result of the whole list to the packages containing only OpenMM into it. And OpenML, of course, it's not installed, so we got nothing. And let's get a list of all packages in the repository. And yeah, that's the better results. That's probably what we want to install. And installing is as simple as saying sudo apt install and the name of the package, which is lib openmm 7.7. And we are done. All right. And at last, let's install the image editing program, GIMP. So we can run the command sudo apt install GIMP for it, accept, and it's going to be installed in a moment. I'm doing that because GIMP, if you are not aware of it, is a very useful open source image manipulation program. It's available for all platforms, including Mac and Windows, and it's small and efficient. I've used GIMP for pretty much everything I needed to do with figures for publications. It's great for things like cropping images, combining them, adding text, and drawing lines and shapes. All package managers function in a similar way, but of course, there are differences in the syntax used for each one of them. It's also important to mention that you can install and run a different package manager than the default. Okay. Any questions about package managers so far?
Maybe it's a good time now for another break too,
Oh, it's
or depending on how much
see.
is left.
Yeah, let's see. Actually, it's not much left.
Sure, we can carry on.
Actually, yeah, let's carry on for about 3 minutes, and then it will be break before we'll go into a different topic.
Perfect.
All right. So the final features of the operating system we'll discuss is security, stability, and virtual machines. So some GNU Linux distributions are considered the most secure and stable ones these days. The fact that the code is available to everyone isn't really a security threat, as you might think at first, but rather it's its advantage because security and other bugs can be identified and worked on quicker. And when a security breach is identified, lots of people can work on it and propose fixes. Windows, on the other hand, is considered the least secure and stable of the three. Given that it's the most popular OS, most malware is developed to attack Windows OS 2. One of the features that sets Windows apart from other operating systems is its registry. The Windows registry is a database that contains all application settings. While this database is often referred to as a single point of failure, in a sense that it's a part of a system that if it fails, it will stop the entire system from working. And the registry is known to be susceptible for corruption from viruses, faulty hard drives, or even improper application uninstallation. Because, well, it's a single global database, it affects the entire operating system. As you install applications, the registry grows, and the registry searches will take longer, eventually slowing down your computer as a result. And as you remove applications, pointers to deleted files often remain in the registry, also slowing down your computer. So which OS is the best, you may ask? Well, the truth is the operating system doesn't matter that much for most people these days. And there is no such thing as the best OS. So you're better off using the one you are most comfortable with. Even so, each OS is still unique. There are some scientific applications that aren't available on all platforms, and some that don't work well on all operating systems. So you may be in a situation when it's a good idea to use several OSs at the same time. For example, you may use Linux working on HPC clusters, coding, and Windows for Office applications. So, okay, in the next session, we will look at how to run several operating systems simultaneously on a single computer. And before this, I think it's a good time for us to take a 10-minute break.
Perfect. I'll pause it.
So exploring operating system in a virtual machine. So our next topic. So yeah, using a virtual machine may be a good option if you are undecided between different operating system or want to try another OS. Having a quick way to install a specific Linux distribution for testing code and debugging software problems is very useful to me, and I often use it. Also, for those preparing to work on HPC clusters, it's a good way to get familiar with Linux commands. VirtualBox lets you run multiple operating systems simultaneously on the same machine. While most open source GUI programs, like, yeah, why would you want to do it though? While most open source GUI programs are now available for all platforms, there is still a great deal of community developed software on GitHub for scientific and engineering problems that only runs on Linux. So it may be helpful to have Linux working alongside with Windows on your machine. I'll quickly demonstrate how to install an operating system using VirtualBox and use it, and how it actually works. Oh, let's jump to VirtualBox. So this is VirtualBox Manager. You can download it from the website. It's really easy to install. And when you open, you will be presented with this type of a screen. And what you want to do if you want to install a new operating system, you need to click on New, and it will ask you to provide a name for it, which could be anything you want. In this example, I will show you how to install Ubuntu on Ubuntu. You can change folder on where to install, and the default is in your home directory and VirtualBox VMs. All you need to install a distribution is to download an ISO image of the operating system. And you can go to the website of the Linux distribution and find ISO image there. Now, many distributions provide small net installed images Those ones are really small and fast to install, but they will install a basic core set of utilities, and they will start you in the single user mode, meaning that you will not have a desktop. You will just start it with a terminal. So you can look up the documentation. It's really easy to add a desktop to those virtual machines to have a full-fledged Linux distributions. Or you can grab an image that includes everything. So typically, full desktop is about 6 gigabytes. It will take longer to install. So, I mean, what you need to do here is simply to browse to where your image is. And this is the Ubuntu image that I have downloaded to my computer. You'll open it. And you can click finish, but you probably want to go through those settings as well. In the unattended install, you can create a user. Well, this is default one and the default password. You probably won't change it to your username. I use the same one and change a password. Something. Oh. Okay, we are all good here. Now in hardware, you can choose how much memory do you want to allocate to this machine. Well, I have 16 megabytes installed, so I can afford to let virtual Linux use 4 gigabytes. The number of processors, I'll set it to 4 out of 16. And the hard disk, you can also change how much storage do you want to have for this virtual machine. And basically that's it. You click on finish and it will do its thing. It will take a while, so I will not be waiting for it to finish the installation. Yeah, here it's booting up. And then it will switch to graphical installation mode and do its thing. It will take probably about an hour to install Ubuntu, and after that, you can start using it. So I think I'm gonna stop it. Details. Stop. Yeah, sure, it's going on. Well, you can go to here to stop, and I just want to power off it for now. All right. So this is another two distributions I have already installed, and one of them is already running on my computer. I'll quickly show you how Debian Linux distribution looks like and what you can do with it. So yeah, here we go. I have installed VS Code here to do the coding. And open it, and there is some Python examples here, which we can quickly run. And you see this just draws a three-dimensional figure. Well, see, it's working quite well. And smooth. And before, when we were looking at the package managers, I have installed in this system GIMP. Let's have a look where it is. So here's our GIMP. You can open files and do your editing here. Draw lines, add text, descriptions, adjust colors. Well, pretty much anything you want. All right. Any questions? Oh, yeah. So you see that you can install at the same time several different distributions, and you can actually run them at the same time. And it doesn't have to be Linux. It can be any operating system. It's a good way to try different distributions, and sometimes when you're debugging problems as why some code works on one distribution and not on another one, you can quickly spin it up and figure out what's going on there. And you can simply close the window if you want to quit. The nice thing about VirtualBox is that those distributions, that operating systems, they are actually separated from your system. They kept in separate directories. And well, you don't have to worry that they can mess up something in your computer. And once you are done of that, or done with, then you can simply delete those directories. And there will be no trace left on your system. Okay, let's go back to the slideshow. Well, it's not the only way to run Linux alongside with the Windows. You can have a dual boot system, but it's of course more complicated, and there is a more danger that something will go wrong and something will be messed up on your laptop. Or you can use also Windows subsystem Linux. Windows subsystem for Linux lets you run Linux directly on Windows without the overhead of virtual machines. And with the latest release of Windows subsystem Linux, even graphical Linux applications can now be run on Windows in the fully integrated desktop environment. So yeah, the bottom line with operating systems is whatever operating system you choose, it's fine as long as it allows you to do what you want. So, okay, we discussed operating system. So let's discuss how to use operating systems in computers. So when you want to use a piece of software that didn't come with the computer, you obviously want to install it. And all computer requires certain hardware components or other resources on a computer in order to function effectively. Most software vendors list minimal and recommended system requirements. The system requirements are usually viewed as guidelines rather than absolute rules, though. Generally, system requirements indicate which computer configurations will be the most suitable for a particular software. So how to check if your computer meets the computer requirements? The most common requirements are the physical computer resources such as processor, memory, GPU storage, or operating system. On Windows, you can do it from the task manager. On Mac, you can go to about this Mac, more info, and system report. Where is it? Well, I mean, basic informations is given here about your chip, serial number, and if needed, yeah, here's at the bottom page is a system report, which will give you more information about your computer, such as memory, chip, performance, etc. So file extensions. Let's discuss file extensions. What is file extension? A file extension is a suffix added to the name of a file to indicate what type of data is stored in the file. A file extension comes after the period in a file name and is typically made up of 3 characters or 4 characters. Well, however, there are no strict conventions about the length of file extensions. They can be as short as 1 character, for example, .c, .m, .f, or C, MATLAB, and Fortran files. 3 to 4 character extensions are simply convenient. They are not too long, easy to recognize and remember. And at the same time, they permit to describe a variety of data types, such as TXT, doc, PNG, PDF, CSV, etc. A file name can include multiple periods. In most cases, the extension includes only the characters after the final period, but there are exceptions, however, such as .tar.gz, for example. This extension indicates that the file contains a tape archive tar data file, which is then compressed with gzip. So to read such a file, you need first to unzip it and then unpack their archive. Normally, tar program, modern tar program can do both the steps at once. An operating system might rely solely on the file extension to determine which application to use to open it. Or it might also rely on metadata stored inside the file. Well, each operating system varies in terms of how it uses extensions when matching files to applications and to the degree to which it uses these extensions. Windows, for example, relies heavily on file extensions, and Windows programs will not open files without them. Linux and Macs rely on extensions when they are available, but they typically permit to open files without extensions as long as you are using the right program. If you have file with an extension that is not recognized by operating system, you can manually associate it with a program. For example, if you have file with some unstandard extension such as .ent, you can click on it, then click open with. It will give you a choices of applications, but if you go to other, it will show you all available application, and then you can associate any application you want with the file and make it a default. So yeah, there are some examples of extensions and the types of files that are normally associated with such extensions here. Yeah. How are we doing on time? We have 30 minutes left. All right. We actually covered most of the important parts. So let's talk about what approach you should take if you encounter any problems and want to identify and resolve them and fix the problem. When you're doing troubleshooting, the first step is gathering information on the issue as much as possible, such as behavior that is not desired or a lack of functionality that you expected to have. So the first thing to do is to identify exactly what is it that your computer is not doing that you want it, or what it is doing that you don't want. And think of what can possibly cause the problem, and write down those causing. So identifying the source of your computer issue will make finding a solution easier. Make a list of things that could be causing the problem. The process of elimination may help you to figure out what's going on. One by one, you can test each one of the items on your list, starting with the most likely cause of the problem. Take a note of any error messages you encounter when you are trying different things. When your computer gives you an error message, make sure you write down as many details from this error message as you can. And using the internet is a good starting place to start searching for a solution. Other users may have encountered similar issues, and solutions are often posted online. Google is most effective when you search for specific error codes and very detailed problems. It's less useful for general questions like, my PC is running slowly. If you search for a solution to your problem, remember to include all the relevant details. You can also locate the developer or manufacturer's official support forums. Search for things like model number or program name version and what you want to do with it or what errors you are experiencing. You may find there is a particular fix available or advice from other users. And for smaller freeware programs, you may even find posts from the developer. So yeah, write down your steps. Once you start troubleshooting, you may want to take a note of each step. This way, you'll be able to remember exactly what you've done and can avoid repeating the same mistakes. Restarting the computer is a good thing to try. This can solve a lot of basic issues you may experiencing with it. Windows also have a built-in rollback feature, System Restore. It will undo recent changes to the registry and hardware and software setup of your computer. without affecting your personal files and photos. It's a good place to start if something has very recently gone wrong. Windows also has a safe mode that can be used to uninstall programs or devices or run fixes. If you can't get into Windows normally, safe mode starts Windows in a basic state using a limited sets of files and drivers. And if a problem doesn't happen in safe mode, it means that default settings and basic device drivers aren't causing the issue. Observing Windows in safe mode enables you to narrow down the source of a problem and can help you troubleshoot problems with your PC. And up until Windows 10, booting up a computer in safe mode was fairly easy. Pressing the F8 during boot up allowed you to access the boot menu and select safe mode. It's more difficult to enter safe mode now in Windows 11. In Windows 11, to give you the option to enter safe mode, the boot process must fail 3 times in a row. You can actually simulate failing to boot by turning off your computer while it boots. So 3 failures in a row will cause Windows to restart into automatic repair mode, where you can activate safe mode. Yeah, well, you can find written instructions and video tutorials on how to do most tech-related things on the internet. So yeah, look for them. Also, how to keep your computer in good shape. So pretty basic things we will discuss. The first one is that it's very important to update your operating system and software on a regular basis. Well, you can't overestimate it. And why should you do this? The most important reason is security. Hackers discover new security flaws daily and exploit them to commit attacks. Upgrading to the latest version of operating system will patch known security flaws and make your computer more secure overall. Further, you'll have access to the latest features, including increased stability and responsiveness. And the latest version of your OS may make it even easier for you to install new applications. Keep your antivirus software up to date and frequently scan your computer for viruses. And well, it's best practice is to organize files into folders. Keeping multiple files on your desktop can slow down your machine. But if you organize similar files into folders where you can easily find them, that will help you a lot to navigate them. And this will also help streamline the cleaning process when it comes time to delete unnecessary items. Delete your unused programs from your computer to free up storage space and clean the registry. If you running operating system from the mechanical hard disk drive, defragmenting it to restore performances may be required when needed. In the past, computers required to be regularly powered down or rebooted, but new computers can go without power cycling for a long time, for months. However, if computer becomes unusually sluggish or some programs do not behave as they should, even they are restarted, then rebooting your computer is the first thing you should do before trying to solve the problem with other tools. And clean up your storage. You can free up disk space on your hard drive by running disk cleanup. This will clean out temporary files as well as delete big attachments and other types of files. The Windows Task Manager is a powerful tool, allowing you to manage tasks and start up programs, as well as monitor system. Using Task Manager, you can find out how your computer is performing and what programs are running. This program reports CPU load, GPU load, logged in users, and details of input-out processes. The equivalent of Task Manager in Mac OS is Activity Monitor, which you can access from Applications menu, starting on another screen. Yeah, you can select which processes to show. You can show only your processes or all processes running on the system, and you can sort them by CPU time, CPU power, etc. You can look at CPU, memory, energy, disk. It's the same idea with Windows Task Manager. It's very important to keep your computer secure when you are working on it. The topic of computer security has many aspects, and we'll start with passwords. You should use a different password for each account. Never use same passwords for several sites. When breaches expose credentials, all accounts that share a password are exposed. And of course, it's impossible to remember all passwords, especially strong passwords. So get a password manager like Dashlane, LastPass, or RoboForm. With a password manager, you don't have to remember strong, unique passwords for all your accounts. The password manager stores them for you and even helps you to generate new random ones. A password manager is like a digital keyring. It helps, it keeps everything in one secure place for easy access. So generate a strong master password, which is at least 8 characters long with 3 different types of characters. And yeah, never use dictionary words or even a part of a dictionary words for passwords. These are really easy to crack. Alternatively, you can use passphrases. Passphrase is easy to remember because it uses a combination of dictionary words, but passphrases are known to provide a good level of security. Yeah, and here are the links to some of the password managers which are offering free options. Oh, clicked on the link. Let's go back to slideshow. For accounts, for your accounts that require enhanced security, always enable MFA if it is supported. There are many ways to enable MFAs, such as authenticator, security USB keys. Just touched my security. There we go. Yeah. There are many ways to enable MFA, such as authenticator apps, security keys, email or SMS login confirmations, so biometrics. You just need to pick a method that works for your services. With a two-factor authentication, it's impossible for someone to break into your account with a stolen password. Do you need an antivirus? Well, it somewhat depends on the operating systems. Windows and macOS include protection against viruses in one way or another. Microsoft Defender antivirus is in addition to providing antivirus protection, also manages other security features such as Windows Firewall. However, yeah, there were reports that it has some limitations, and you probably can improve your protection by installing a third-party antivirus such as Bitdefender, Avast, or AVG. macOS includes security by design. The operating system resides on a read-only drive partition, separate from all other programs. So to infect another program, a virus needs to modify that program, and that's not allowed in Mac OS. To steal private data, a banking Trojan must read memory belonging to your browser, which is likewise not allowed in the macOS environment. Application in the macOS environment are isolated and limited to accessing their own resources. macOS also includes a technology called Gatekeeper that is designed to ensure that only trusted software runs on your Mac. Well, but while Macs aren't as vulnerable as Windows boxes, they can still get malware. Phishing. Always be suspicious to any unexpected email or unusual request, especially if it concerns financing, login credentials, or creating a file or link. Don't open attachments from unknown users, poorly written vague emails. Well, sure, always think twice before clicking on any links. Phishing emails today are the result of well-organized criminal businesses, and they are very inventive in crafting messages that get open. When in doubt, look at the email header and see where it actually came from, and then check if the domain it came from is blacklisted. And never give your passwords to anyone. Remember that you will not be asked for your password by the administrator. They shouldn't have access to it, and they don't need access to your password for anything. There are many ways that data can be lost, such as hard drive failures, ransomware attacks, or even error or theft. Don't let your important computer data disappear. Always make a copy or archive it regularly. And it's best to store backup copies separately from an original device. It's recommended that you make 2 copies of your data. So one local copy, maybe on a different device, and one offsite copy. It typically means having a backup of your data on an external drive, a backup on a cloud service, and your original data on your computer. Well, we still have some 15 minutes left. Okay, let's talk a little bit about how to choose the computer. So what you should get, a desktop, laptop, or Chromebook. Choosing a computer is always about making trade-off decisions. In most cases, you'll have to make some sacrifices unless you don't care about cost. Depending on your needs, you can choose between powerful desktop or portable laptop, faster CPU or longer battery life, lighter weight or less expensive, better and better display or less cost. The trade-offs really depend on how you plan to use the system. The point is, before you choose your platform, it's important for you to identify your needs. It might be that you have a limited budget or that you have a specific pressing need. But unless your priority is to get your job done as soon as possible, well, there is actually fairly little need to spend a great deal of money on the top of the line components. Yeah, well, in my opinion, there are quite a few differences in the criteria for selecting a desktop or computer or laptop. The size, weight, and screen quality are among the most important factors for me, for example, but you may have different needs and your priorities will be different then. A good start point for choosing the right platform is to identify your needs. So desktop, laptop, or Chromebook, what's the differences between them? A laptop or a Chromebook, well, they are logical choices if portability is your top priority. But in general, however, desktops are much better products in the laptops. And there are several reasons why desktops are superior to laptops. Well, first, they are more powerful. One of the main reasons to buy a desktop computer is its power. When all components might fit into a small device, laptops are limited in their power and performance. Only desktop computers offer top-of-the-line performance. You can expect to pay significantly more if you want a laptop with specs similar to a desktop. Also, while modern high-end laptops are fairly fast, top performance is available only in short bursts. Laptops are not really designed to handle high loads for extended periods of time. While there is no doubt that power is important, it depends a lot on what you intend to use the computer for. When it comes to browsing internet, watching videos, and writing documents, desktops have no advantage over laptops. Yeah, there are a few things. While desktops are better compared to laptops, but yeah, the bottom line is laptops do not offer a high level of flexibility. There is a limit to how many ports can be installed in a laptop computer due to space restrictions. So if you want to add a new peripherals, this can also be problematic. And there are also Chromebooks. Since Chromebooks take advantage of cloud surfaces, they generally have lower processor speeds, less RAM, and less local storage than laptops. At first, they were essentially low performance, so-called thin clients designed and optimized for remote access. But this is changing with the evolution of Chrome OS. High-end Chromebooks can run Linux and Android applications locally these days. Well, overall, Chromebooks are excellent for students, office workers, and anyone who works entirely on the web, but not so great for people who need more advanced capabilities of locally installed software. So I think I'm gonna skip this slide. Yeah, when to fix the PC and when to upgrade. That's important thing. Well, it's tempting to look for a new computer when a computer slows down or slows other signs of trouble. But in order to get the most out of your investment, you probably want to extend its lifespan as long as you can. There is a lot to consider when you are deciding whether to repair or upgrade a PC. Eventually, any computer will get too old to maintain. 3 to 7 years is a reasonable lifespan, depending on build quality and progress in new technologies, of course. Computers that are too old or flawed to be worth fixing, don't waste time fixing a 10-year-old machine, for example. Before trying to upgrade your computer, make sure this isn't a software issue. So test your computer for viruses and malware and ensure there are no infections. Use Activity Monitor and Task Manager. If you see a single program consuming all your CPU or RAM, uninstalling it and replacing it with an alternative may speed things up. Operating system could be also corrupted somewhere. So wiping out and reinstalling operating system may help to fix the problem. Now, if this doesn't work, you might need to upgrade your hardware. You can check your CPU and memory usage in the Task Manager's Performance tab. And in case the CPU or memory usage is particularly high, you'll know which component needs to be upgraded. It's also possible that one of your components is failing entirely. A program like HDTune, Crystal Disk Info, or a vendor's hard drive utility can be used to test your hard drive and determine if it's failing. You can also check your RAM as well. RAM failure could slow down your computer down, yeah, it not only can slow your computer down, but could also make it impossible to turn it on, or it might cause it to shut down randomly. So you can run a RAM test like a mem test, which will check each stick and see if it's good or not. If computer does not turn on, removing all memory sticks except one will help you to find a faulty one. So to determine whether an upgrade is worth your money, look at how much it will cost. I would not recommend fixing an old, more than 5-7 year old computer if its repair cost is more than 25% of the cost of a new computer. But a simple upgrade to one component can usually extend the lifespan of your computer by a couple of years if it's causing a slowdown. And I think I will end at this. This last slide, I will list all training resources, all extra sessions and self-study materials which are available for different specific applications that you may want to consider taking. Yeah, and well, thank you for attending.
Thank you, everyone. I'll stop this.